what you'll ever do to confuse.
Alright, we're going to start off with the first grade example of an inverse function. 1 plus 1 equals 2. So, to check my answer, I would do 2 minus 1 equals 1. Inverse function in the first grade. Alright, so as I said before, this was a first grade example. Now let's get a little bit more complicated and go with the 5th grade example. Alright, 5th grade example would be x plus 2 equals 5. The inverse function of x plus 2 equals 5 would be x equals 5 minus 2.
Wait, yeah, is there an inverse time?
5th
The inverse time, I'll just write it down.
grade.
So let's say you're in high school now. Let's get into a little algebra of the equation, and maybe even some calculus. Alright, so this straight line right here is y equals x, just your normal line. And then this curved line is y equals sine of x. So these points are pi over 2, 1, and negative 1, pi over 2. To find the arc sine, which is also the inverse of the sine, so it would be sine to the negative 1 of x, you have to graph the opposite of the sine. So it would look like this. Now, the ordered pairs just simply switch themselves when you're doing the arc sine of the function. So you'd end up with 1, and then pi over 2, and then pi over 2, and then negative 1 for these 2 point ordered pairs.
Alright, so as Ben was saying before, this is the difference between sine and the inverse of sine. Now I'm going to show you the difference between tan and arctan. Now tan is obviously on a different scale as sine. So, for tan, as it is approaching this line, you start off like this. And then this one, as it's approaching this line, it's coming up and through and down on the bottom, coming over and out. Alright, and that is the actual tan. Now we're going to show you the inverse of tan, the black marker. The inverse of tan just starts out here a lot closer to the line, comes up and through pretty simply like that. And that is arc, tan, and
A simple tip to find the inverse function is to switch the domain and range.
Alright, so we're talking about inverse functions here. Now the basic concept of an inverse function is basically the opposite. Inverse means opposite. So let's say, like going back to our first grade example, 1 plus 1 equals 2. So the opposite of that is subtraction. So 2 minus 1 equals 1. So that's the bare bones inverse function. Alright, so now let's get into two variables, an x and a y. So let's say 4x minus 2y equals 8. Now, that's just the normal function. To find the inverse of the function, we have to switch the x and the y. So you end up with 4y minus 2x equals 8. Alright, so if we take the derivative of the inverse of an equation, then that ends up being the reciprocal of the derivative of the parent equation. So let's just say that y equals x squared and the slope equals 4. So it's going to look something like that. Now, for the opposite equation, it's going to end up being 1/4 because it's the derivative of that. So it's going to go like that.
Alright, so as you can see here, we start off with y equals sine to the negative 1 of x. We're going to want to take the inverse function of that, so we got the sine y equals x. Then we come down to this line, we got the derivative of sine y equals the derivative of x. And the derivative of sine y equals cosine y equals 1, because 1 is the derivative of x. And that ends up giving us the derivative equals 1 over cosine y. And that's how you find the inverse function of sine x. Alright, so the last thing we did was the inverse of sine x. Now we're going to get a little bit more complicated and try to do the inverse of tan x. It starts off with a y equals tan x, the inverse of tan x. So we drop it down into tan y equals x, because that's the inverse of it. And the derivative of tan y equals the derivative of x. So the derivative of tan y is secant squared y equals 1, because 1 is the derivative of x, as we all know. And then we get dy over dx, which is the derivative, equals 1 over secant squared y, which also equals, if we get the derivative of that, equals 1 over 1 plus tan y squared. And as you can see before, the tan y equals x. So we'll end up with just a 1 over 1 plus x squared. That's how you find the inverse of tan.
A real-world application of inverse function is to find unknown angles.
Alright, another real-world example. For all you scientists out there, you're always converting Celsius to Fahrenheit and Fahrenheit to Celsius. With inverse function, that makes it all possible. So, to find Fahrenheit, you take the function of Celsius times 9/5 of Celsius plus 32. Now, I want to find the Celsius. So, I'm going to take the function of the Fahrenheit times 5/9, which is the reciprocal of that, of the Fahrenheit, and then minus 32 to find the inverse. And that's the function of how to find Fahrenheit from Celsius. Sure.